right, let's start talking about the Big Bang and the atom. And first, we're going to start with an introduction on this lesson. So, the big question is, what are the foundational topics of evidence supporting the Big Bang theory? Well, there are four of them, and we are going to be discussing them throughout this unit. They are the composition of the stars, the hydrogen to helium ratio, redshift, and cosmic background radiation. We are able to use chemistry and these portions of chemistry to really dive deep and look at Big Bangs and the origin of the universe. Very cool. So, the next two questions are, what is the significance of protons in an element? And how are protons used to identify the element on the periodic table? So, let's dive in. Well, protons is actually the atomic number, and that number is used to ID the periodic table. Now, on the periodic table on your screen, if you look over here, the atomic number is on the top. Every different element has a unique atomic number, and that is the number of protons in that element. Please, the atomic number is always a whole number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are all atomic numbers. The atomic mass, which you see on the bottom here, is an average atomic mass. So it's going to be in pieces, so like 28.086. Also on the periodic table, we're going to be given the symbol and often the name. So please note that the periodic table is organized by atomic number. So the periodic table, hydrogen has an atomic number of 1 because it has 1 proton. So it's on the very top left-hand side. And then helium, which has an atomic number of 2, moves next. It's an increasing atomic number. Please note that we do not use atomic mass to identify elements, only the atomic number. So if we look at carbon, so carbon's over here. Carbon has an atomic number of 6, which is the number of protons. If we look for neon, neon has an atomic number of 10, and that is also the number of protons, which is also its atomic number. And what has an atomic number of 26? That would be iron. Now take a moment, pause this video, look at the periodic table, and see if you can identify these items. Please identify the atomic number and mass, placement on this periodic table, as well as the symbol and the name. And if you have any questions, let me know. Okay, let's try a quick challenge. What element has an atomic number of 16? How many protons does tungsten have? And what does the atomic number represent? Quick, pause this video, write down the answers. Let's see, discuss with your neighbor, and let's see if you're right. Okay, now that you're back with me and you've paused the video, the element that has an atomic number of 16 is sulfur. Tungsten has 74 protons, and the atomic number equals the number of protons in an element. Awesome job. If you need to review that information, let me know. Moving forward, the next big question is, what are the components of an atom as well as their characteristics? So there are 3 parts of an atom. That's proton, neutron, and electron. A proton has a relative charge of +1 or 1 plus. We talk about a relative charge because that's the charge in comparison to everything else. So it's easy to say 1, 0, -1, then it's small numbers. So proton has a relative charge of 1 plus, a neutron has a relative charge of 0, and electron has a relative charge of -1. The mass of a proton is just about 1 AMU, AMU being atomic mass unit. Because if you look at it, it's very, very, very small. It's 1.0027276 AMU. So it's just about rounded to 1 AMU, and is located in the positively charged nucleus. Nucleus is positively charged because you have protons and neutrons in the nucleus, and protons have a relative charge of 1, and neutrons have a relative charge of 0. Neutrons have a mass of just about 1 AMU as well, is slightly larger than a proton, and it's also located in the nucleus. Electrons, on the other hand, have a relative charge of -1, but they're really, really, really tiny. They're 1/1840th of a proton, and it's located in the orbits or shells surrounding the nucleus. Electrons may not go into the nucleus. What are the locations of the parts of a periodic table? So we talked about protons, and then we talked about how they looked at the protons looked on the periodic table. Then we looked at the different parts of the atom and how they relate to an atomic structure. But now, putting that all together, what are the different parts of a periodic table? So, vertical columns are called groups or families, and they go up and down. 1 through 18 are your groups. Periods are your horizontal rows, and they go side by side. Metals are on the left side. If you look at this line here, like this staircase, the staircase goes between boron, aluminum, silicon, germanium, arsenic, antimony, tellurium, polonium. There's that dark line. That is the metalloid line, and metals are to the left of it, or generally column 13 through column 1, or 1 through 13, are metals, and they're shiny, malleable, meaning they can be made into items. They conduct heat and electricity. Non-metals are to the right of that metalloid line that we just talked about, or column 14 through 17, just about. They're not shiny, they are very brittle, and they do not conduct electricity. Metalloids border the line except for aluminum. So that would be boron, silicon, germanium, arsenic, antimony, tellurium, polonium. Sometimes astatine can be considered metalloids, and they have properties that go between metals and nonmetals. Group 1 is considered an alkali metals. That's their name. Group 2 is alkali or alkaline earth metals. Then 3 through 12 are your transition metals. The name for group 17 or family 17 are the halogens. The name for group 18 are the noble gases. And every other family is named by first element in the column. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, boron, carbon, nitrogen, and oxygen. And then you're adding the word family. So for example, if I'm looking at column 3, it would be the scandium family. If I'm looking at column 13, it would be the boron family. If I'm looking at column 16, it would be the oxygen family. And please note that this jump down here, 57, 89, to the elements down below, starting with cerium and thorium, they are actually part of the metalloids, and they're named as a series, not a family. The top is the lanthanide series because it follows the element lanthanide, and the second is the actinide series because it follows the actinide element. Thank you so much. Thank you for watching.